What's the difference between static cast, dynamic cast, casting with type, like parentheses? So casting with parentheses is a mix of the other ones, as in it'll try one of them. If it can't do, I don't remember the exact order, but let's say it'll try static cast. If it can't do static cast, it'll try reinterpret cast. If it can't try reinterpret cast, it tries, I think that's all it does. And it does a const cast first or something. So what's the difference? Well, so dynamic cast is typically a runtime check, whereas all the other casts don't have a runtime check. So that's one major difference. And of course in C++, whether it has a runtime cost or not is important. Static cast does many things. Static cast for pointers and for references, make sure you don't go, you either go up the hierarchy or down your hierarchy. So for an inheritance hierarchy, a class hierarchy, you can static cast to a base class. You can, let's use an example. Language C++. So struct my base and struct my derived my base. And if somewhere we have some pointer, which is a MyBase pointer, and we can static cast that to my derived pointer, and this would be, its type would be my derived pointer. Right, all the casts will give you the type in the brackets. But this static cast, it's not necessarily safe, but it's allowed, like it'll compile, because my derived is related to my base. If we had another class which wasn't related to either my base or my derived, well, if it's not related in a hierarchy to my base, then my other, it'll fail to compile. So for this use case, static cast helps you catch errors where you're casting the wrong, like unrelated objects. That's for pointers. For integral types and floating point types, and for other kinds of types, it'll just do a conversion. So static cast to int from 3.14, it'll give you an int which is 3. This is totally different than, in my mind, than this kind of thing. So if you see a static cast, it could be either this kind of thing or this kind of thing. Well, not this kind of thing, but it'll be for a pointer type or a reference type, it will be through some inheritance hierarchy or something. And for including void, and for non-pointer thingies, it's going to do a conversion. So I rarely see people do conversions with static cast for non-primitive types. I usually see it for only primitive things. So that's basically static cast. Reinterpret cast is if you did want this to compile and you're doing weird things, reinterpret cast will let you cast pointers of unrelated types or references of unrelated types. Reinterpret cast also can let you convert integral types into pointer types and pointer types into integral types, and also function pointer types and stuff. You use that a lot less than static cast. use reinterpret cast a lot less than static cast. And const cast just changes const and volatile. And so the parentheses one will figure out, okay, are they both pointer types and are they both related? Well, I'll just use a static cast. Are they both number types? Then I'll use a static cast. If they're both pointer types and they're not related, I'll use a reinterpret cast. If there's like constant stuff and it like changes, it'll throw in a const cast in there to remove the consts or add the consts or whatever. If it's given a pointer type and if you do like int p, it'll turn this into a reinterpret cast because a static cast can't do it and a dynamic cast definitely can't do it, and whatever. This kind of cast with parentheses is never going to do a dynamic cast. It'll either do a reinterpret cast or a const cast or a static cast or some combination. So when do you use it? Reinterpret cast. So let's look at static cast first. So here I'm using static cast to void to silence a warning. I probably should use maybe unused here. This is a better thing to do to silence the warning. So I'll do that. Silence warning. Whatever, I'll do that later. In this case, this is another use of static cast in my project. I'm doing pointer arithmetic to figure out, I have a pointer and I have an array and some pointer into that array. What's the index? Like, is it the very beginning, in which case it's 0? Is it like the end, in which case it's size? So I'm doing subtraction to figure out the index because I need to know the index. But that gives me a signed number back. And string view takes an unsigned number. So in order to avoid warnings, I'm using a static cast to convert this. This is a pointer diff t into a size t. So that's just like an integer to integer conversion. Here we have, this is a macro in a library that isn't mine, and I need to make sure that it is a 32-bit unsigned integer. Otherwise the compiler complains with a warning, so I'm using a static cast here as well. So this is like a pointer style static cast. So this is a different kind of static cast with different rules than integer conversions. Let's see, chunk debuff. I think this is a pointer to void, and I'm converting it to a pointer to bytes. So in this case, there's a C API here, which it has a debuff thing, and that'd be like struct chunk type. I don't know what the type is. Void debuff. So it's a void pointer. It's really just a pointer to a buffer. So I'm treating that as a bunch of bytes, and static cast lets me do that. I could also use the parentheses cast. The problem with parentheses cast is, what if it wasn't a pointer? What if it was a number? What if debuff was a number? Then I'm converting, unwillingly converting some number into a pointer, and that's not what I intend. Let's say I forgot const there, and debuff was declared as a const void pointer. If I just write this, it'll give me a compilation error telling me that I'm stripping out the const. which is shouldn't be done implicitly. But if I use a parentheses cast, then it'll drop the const and it'll convert the pointer from a void pointer to a byte pointer. So that is not what I intend. I don't want to strip the const. I just want to convert void pointer to byte pointer and preserve its constness or whatever. Well, you can add const with static cast, but anyway, that's what I'm doing for this. Here I'm given an R value reference, and I want to make sure that I call an overload of myself with the L value reference. So I can technically remove this cast, but this is a readability cast where I'm telling the programmer what the type of this thing is, so that they can, when a programmer looks and is like doing overload resolution manually, they'll pick this version instead of the version with the 2 ands. Because if it picked the version with the 2 ands, the R value reference version, then that would be this function calling itself, which is not what I intend. So I'm making it clear that I'm not doing that with this use. This is a pointer. I'm casting it to its parent, its base class. So I have an OString stream. And this is like OStream is the base of OString stream, or is a base. And I'm casting it here so I can get. It's not behaviorally different in practice. However, there's some static analysis tools which get confused by this because it's macro magic nonsense. So doing this makes a certain tool better, but it really doesn't do anything interesting. Here's another pattern that's common. It's similar to the buff thing, but instead of casting it from void pointer to bytes, I'm converting it from a void pointer here to, so I allocated some memory of type func on the heap using makeUnique. And that's the closure for some thread. I think this thread, yeah, threads. So this is a spawn thread routine. So I allocate some memory to store state for that particular thread. Then I call the third create function, which is a C function. And I give it the pointer to that closure. And when the thread is created, this routine gets executed, but all I get it back is a void pointer because it's a C API. So I need to convert that back to the strongly typed closure, statically typed closure, the func pointer. So this is a common pattern if you're dealing with C APIs and you're doing callback style things. It's to static cast. All right, thanks, Link Slumps. Thanks for encouraging me to use VS Code and wasting my time on it. Hopefully you're still around, Tris, and you're learning stuff. And here you see another cast to void. So this is because this I can't use and may be unused. Well, I mean, it technically could, but so normally when you call, normally when you call release on a unique pointer, so release returns, it clears out the unique pointer, but returns what the pointer was as a raw pointer. Here I'm saying with the cast that I don't care about that resulting pointer, and I deliberately don't care. Not like I accidentally forgot to use the return value. And that's because by creating this thread, I transferred ownership of the object, the unique pointer, to over here. So I don't want both the spawn thread function and call routine freeing the memory, because that'll be a double free. So to express the transfer I'm releasing on the unique pointer, and to express that I really don't care about the result of release, I am casting to void. Yeah, so C only has the parentheses cast, which was a good design decision, but C++ has more statically typed stuff in it. Like, it wasn't based around, it didn't have the same background that C had. So it has these dedicated-ish casts. To do certain things. And like, they're pretty versatile. Well, whether that's a good thing or not, you know. Like, static cast void is a weird pattern. You might see people use the parentheses cast for void because it's totally safe. You might see people do this, which I think is fine too. But it's very easy to mix that with this, which is totally different. If there's an asterisk there, that is very different than just void cast. So, anyway, let's look for more kinds of casts. So a lot of these are just number things. Like number conversions. This is another interaction with the C API where we get a thread local variable and we need to cast it to our expected type. Same thing there. Okay, let's look at my reinterpret casts. I don't think I have any dynamic casts because I don't. Oh yeah, I do. So here I'm given an O stream, and I happen to know that it's always an O string stream. But so when you do if you have your C out and you say hello world or whatever, you can actually, like, this is actually an expression. Like, sometimes you may not think about it, but you can say, you know, auto whatever. Like, you can assign that to a variable, or you can call a function. In this case, we're calling a function. We're basically calling make scoped trace of this kind of thing. So in this case, this is not an O-string stream, so this dynamic cast would fail. So dynamic cast with references will throw an exception on failure. Dynamic cast on pointers, like if I did pointer and reference there, if I did this, then this would return a null pointer on failure. And I should ideally check for the null pointer. But here if the dynamic cast fails, it's a programming error, like either a bug in this module or somewhere else. So I do want to return I do want to use the reference version of dynamic cast to get an exception because I just want the program to exit. I could use the pointer version in cast, do an assert, but that's just more code for no big difference. So what I actually have here is string stream. I construct a string stream, and then I throw things into it. So the signature for this operator here, I'll just simplify it. This, like in the standard library, it'll have something like ostream operator left shift ostream and const char pointer. So you can pass in an O-string stream to the left shift operator just fine because it'll implicitly convert it to the base, a reference to the base class. but when it returns, it always returns OStream. So, but it always returns the argument it was given. So because it always returns the argument it was given, and we gave it an OString stream, we dynamic cast to get it back to where it was. We could use a static cast, but a dynamic cast actually does a check, runtime check, to make sure that's the right type. If it isn't the right type, we'll get an exception in this case. And that's just to catch mistakes. This isn't performance sensitive code here, so dynamic cast is fine. If it was performance sensitive, we would use a static cast and maybe a debug only check. When creating your callback function, let me see if I can go back to where that was. That was in this thing. Are you talking about this? Actually, this shouldn't even be and. Pretty sure. Takes misuse of. I'm gonna do some research. So if I use move, then sometimes it wouldn't compile. Well, because I'm constructing one. Yeah, so if I used, well, no, move decays on. Yeah, I guess move is weird. It is, well, okay, so move will do the wrong thing in certain cases. So if I say class my thread routine and operator message, let's call it message, and then some function, say my thread routine tr, and I say my message is hello world, and then I spawn thread with a tr. If I use forward, so this is actually calling, well, regardless of forward or not, this is calling spawn thread with a my thread routine L value reference, because it's not const. It wasn't, the object wasn't declared const, and tr is an L value, so it becomes an L value reference when it's inferred and bounds to this universal forwarding blah blah blah. So hopefully you understand that, because that's not really related to this. I mean, it is in how there often comes in pairs, but anyway, when I do this, well, another way to write that is func of, so here we're saying we're going to construct a func, and the constructor argument is this expression. So for this call, we need to consider either forward or move. So forward or move. So forward, we'll call the constructor, because forward just casts it to its argument type. It'll call the constructor, because this is func, my thread routine ampersand is func, capital F func. this will call this constructor. The forward will call the constructor. Move always makes, well, moves always makes an R value reference, I think, pretty sure. So it'll take whatever routine is. In this case, routine's type is my thread routine ampersand. I might be wrong about this inference, but let's go with it. If I use move, it would try to call the R value reference version. I screwed up my keyboard shortcuts. Now, what's wrong with calling the R value reference version? Well, I'm moving it. That means if I call spawn thread again, the second call, like the first call will call move if I do the move version. That means my message string will be moved into the closure on the heap for the thread, leaving the original one in the tr object to be moved from, which could mean it's empty or it could have the same string, whatever. I don't remember the rules for std string on move. So that means the second call will get who knows what for message. So that's not good. What the caller wanted here was a copy. They wanted the first call to make a copy and the second call to make a copy of the message. If they didn't want the copy, they would write move explicitly here. And that would do that. And if they did this, then the forward version, like the move version wouldn't change, right? Because it always makes the R value reference. But the forward version would turn into an R value reference construction of func, which will do the move. But only for the second call. For the first call, it would still do the L value reference version. Hopefully that explains that pattern. Delete, delete, delete. Does that make sense, Piano Boxer? Oh dear, it's already 9. When you want to preserve the state on the functor. Well, it's not that, because if the caller of spawnfunc does std move of their closure or something, then we don't want it to keep it where it is. We want to move it to the thread. So forward will allow spawn thread to be agnostic on that, on how the closure is created. The closure is created by the caller choosing what kind of things are constructed. I could have been more general and made this like this. I don't remember the exact syntax, but something like this. Break it up for you. So this will do the same thing if there's only one argument. If spawn thread is given like 5 arguments, then it'll construct the func. Well, you also need func here, class func. So if it's given 1 argument, then it won't work because override resolution won't find it. But if you do multiple, then it's as if I called the constructor. This is what makeUnique does. MakeUnique does something like this, and then forwards all the arguments over. But in my case, it doesn't make sense. It could make sense for a spawn thread function to want to do that, but in my case, I don't need that. Because really, I think I'm only spawning threads with like very basic stuff. this is an anonymous namespace, so it's only using this file. So I'm only giving it a lambda with an int and a pointer. So whether I move or not, or copy or whatever, it doesn't matter. It's all the same. Or if I construct in place versus whatever, it's all the same in my particular case. But it's still... So I could have made this use less C++ machinery, but it's like I'm following a pattern. So if I was going to deviate from that problem, that would require mental effort rather than implementing the more complicated thing taking more mental effort. Unfortunately, this is not complex stuff. As far as like C++ complexity ladder goes, it goes much crazier than this. Unfortunately. Anyway, so that's my only use of dynamic cast, is the one I explained earlier. Reinterpret cast I use apparently a number of times. So in this case, I'm using reinterpret cast because the C API takes a pointer to some struct, but it really, like the type of thread info, the function thread info, which is a poorly named function, is it takes a thread info t, which is like something. I think it's a pointer to an integer or something. So thread info takes a pointer to an integer, but really, depending on some constant you give it, like thread identifier info, or here thread extended info, it will actually take different type pointers to different structures. And in order to comply with that API, I'm using reinterpret cast. I could have used the C-style cast, but reinterpret cast is more clearly stating this is something silly going on. It doesn't mean the code's wrong. It just means if you get some weird data corruption bug or something, maybe look at this reinterpret cast. That might be the issue. Whereas the C-style cast is kind of hidden, doesn't have a long keyword to make it more obvious. So that's both of those. Here I am knowing basic C++ if pointer, maybe a bit of class and watch history and 10 learners. Well, I hope you do learn something. C++ is a pretty broad language, so I mean, I have something that I need to look up, which is like I made a mistake, not today, but in the past, where I called std forward with an R value reference, or actually don't know if this is R value reference or not, because C++. So I'm gonna do some research later to see, did I do, I know I made a mistake, but I want to understand the consequences. So even if you know stuff, you can learn stuff. And it's a complicated system. So don't feel bad for not knowing stuff. Here's another kind of common case for reinterpret casts. I have an array of std bytes, and this API takes an array of uint pointer 8t, which is basically bytes. In order to call the API, I need to do some cast, and I can't use a static cast because std byte is not actually related to uint8t. So I need to do something else, and I just use reinterpret cast. Things like this, I should probably make a library function. that allows me to cast between different byte types. Unfortunately, there's many byte types in C++, and they recently added another one, std byte. So it'd be nice because byte casts are pretty safe, so it'd be nice to have a library function to make that less scary looking, like in reinterpret cast, but you know, not all code is perfect. So here's a reinterpret cast where I'm converting a pointer into an integer. And why am I doing this? I don't know why I'm doing this. I could very well have just used a could have used int pointer. I don't know why I have a reinterpret cast here. That's kind of weird. Let's just clean that up, because there's no reason for that. Untested. Excuse. Reinterpret cast. Oh, and here's the same code doing the same thing. Oh, but this is a static local variable. I don't know why I did that. Why I made a... Weird. Here's an actual use case where I am casting a real pointer into a integer type. That's because mockvm deallocate, which is like a free function, it deallocates memory, takes an address instead of taking a pointer. There's good reasons that the function behaves like takes an address like that, but it means I have to do a reinterpret cast, unfortunately, because my code deals with pointers. There should be a corresponding one. I guess not. So where am I allocated the mock array? Passports. That's weird. I wouldn't expect that to... Well, there's an asymmetry. The allocation function gives me pointers, but the deallocation function gives me addresses. It's weird. Legacy C APIs. Here I'm doing the opposite. No, I'm not doing the opposite. No, this is between a pointer and a pointer. So I'm treating some raw bytes as an object, and I need to use launder to do that. You wouldn't need any magic in C, but in C++ you need magic because object lifetimes and stuff. So it's another not stupid thing about C, but a self-inflicted pain point of C++. So if you ever see launder, then don't touch that code. I actually had a bug where I forgot launder once. It didn't actually manifest in anything that I noticed, but yeah. Don't avoid reinterpret cast. If you do a reinterpret cast, you might do launder. Hopefully you're smart enough to know, but you probably aren't. I wasn't. So yeah. This is doing the same thing. I'm not going to explain that. Here's a case that's pretty common if you're on Linux or Mac or Windows. If you do a DLSIM or on Windows get proc address, that gives you a void pointer. But if you want to, in this case, I'm getting the pointer to main, the main function. But I want to call that main function or use it or whatever. In this case, I'm calling it. So I need to convert it to a function pointer type before I can call it. Otherwise, it doesn't know the type of the function, so it doesn't know how to call it. So I use a reinterpret cast. So you can't use a static cast here because you can't. A pointer to a function is very different from a pointer to a non-function. And a void pointer is a pointer to a non-function. So you need to use reinterpret cast, not a static cast. So it's not like a downcast. This is like a weird thing. That's normally not allowed, but it is allowed for DLSIM. It's explicitly allowed for DLSIM and some other things. And it'll happen to work in a lot of other cases. So you might notice this is familiar. This is the type of main, or a type of main. Main doesn't really have a type, but this is just to work around stupid behavior of a library, so whatever. This is dealing with another C API where there's a generic header, and the header has a type field, and if it's this type, then I can use the whole structure is actually of this type, this different type. So I'm using reinterpret cast to convert from that header type to the full type. Actually, let's look at this type. So you'll see the first member is the header. I think there should be a better way to do this that's more safe, because there should be a way to say, okay, your header, the first field is the type you're casting from. So it should be safe-ish. It should be as safe as a downcast, because this is basically implementing like a base class type thing. So actually I could put this as a base class, but I think that'd be a little more confusing. But if it was a base class, I could just use static cast. But I'm not, so I can't. This is similar thing. No, it's not a similar thing. So I'm given some offset into some giant buffer, and I'm told by the Linux kernel or whatever, this is called interface, that at that offset is some structs, which is a perf event data struct. And it guarantees that it's properly aligned and that whatever. And I think I need a launder here. No, I don't need a launder. I'll in practice, so many people don't use launder in this kind of case for C APIs and C structs that you probably don't need launder, and they'll probably change the C++ standard if it's not changed already to not need launder in this case. But I'm still curious if I would need launder. Anyway, the kernel tells me there's some struct there, and it guarantees that it's initialized and everything, so I need to access it. And there's no other way for me to get a pointer to that. That's not my code. Really, 28 CN. Here I'm doing some trickery, which is not safe, so don't do that. Let's skip past that. This is also a not safe thing that I want to rewrite. We've already seen that kind of thing before. We've seen that kind of thing before. So yeah, there's a bunch of different use cases for the casts in the real world. Like, knowing the mechanics of it is very different than knowing how you actually would use it. Like when you would use it, when you wouldn't use it, stuff like that. So